Alright, so now we're on to part 2 of our unit circle lesson. I'm sure you had just a ball filling in the rest of your unit circle here with our angles. Should have gotten 120 degrees, which is 2 pi thirds. 135 degrees, which is 3 pi fourths radians. 150 degrees, which is 5 pi 6 radians, where you did the 180 in pi. We got 210, 7 pi 6, 225, 5 pi fourths, 240 degrees, which is 4 pi thirds, and the next one is 270 degrees, which is 3 pi halves. Continuing on, you got 300, 350, and 360, 330 degrees, which are going to correspond to the radians of 5 pi thirds, 7 pi fourths, and 11 pi sixths. So now that you've done all that, we're actually not done with our unit circle because it has all these like points on the edge. And you need to be able to write down what these coordinates are for the ends here. And the way you're going to get those coordinates is, one, by remembering that on a unit circle, the radius is 1. So this distance here is 1. And that means this point over here on my right side, if you think this is a giant coordinate grid, is going to be at 1, 0, because it went right 1. And on the left side here, it's negative 1, 0. And at the top here, it's at 0, 1. And at the bottom, we got 0, negative 1. So there you go. We got some base coordinates here, but those are the easy ones. We need to deal with these difficult ones that are on the diagonal. Because we know it makes a radius of 1, so this length is 1. But that doesn't mean our coordinates are going to have 1 in it, because coordinates are horizontal and vertical, not diagonal. So you have to figure out, oh, well, how far horizontal and how far vertical is it to this point? Well, luckily, when you think about that and you compare it to your radius here, it forms a right triangle. Oh man, if only there was oh my goodness, there's an angle in our right triangle. And you can use that angle to get these side lengths to figure out the x and y coordinate here. Because we know our hypotenuse. The hypotenuse is 1. You know what? I'm going to change this to a different color so it's a little easier to see. Let's do red. Yeah, so we got our radius here. And we need to figure out the vertical and horizontal component of this. We know the radius is 1. And we know this guy is 30 degrees. Well, this is one of our special right triangles. This is a 30, 60, 90 degree right triangle. And we have dealt with this before. That's why we learned about the special right triangles earlier. Well, if I wanted to get the x value, which I'm actually going to change these. Horizontal is x and vertical is y on our coordinate plane there. So let's go ahead and get this horizontal component. Actually, we're going to get the vertical component first because I know a few things about these special right triangles. If you remember when we were learning about them, we learned that in these, the smallest side is some sort of measurement. And then that would mean the hypotenuse is double that measurement. And then this side here is that measurement times by root 3. Well, knowing that property about these things, if I know this hypotenuse length, I can get this one using that knowledge about the special right triangle. Well, this lets me know that the hypotenuse is double this smallest side length. So if my hypotenuse is 1, what does that make my smallest one? Hopefully you said 1/2. And that is going to be right. This is going to be 1/2 because on a 30, 60, 90 triangle, the hypotenuse is double the shortest length. So I got 1/2 here. Well, if this is 1/2, what's my other leg going to be, knowing that from the smallest one to the other leg is times by root 3? Hopefully you're able to fill in that this is going to be 1/2 times by root 3, which happens to be root 3 over 2. And that lets me know Now that I've done that, this length is the square root of 3 over 2, and this length is 1/2. So I can go over to my unit circle, where I was drawing on before. If this is 1, then this guy here is going to be 1/2, and this is going to be the square root of 3 over 2. And so I can fill this in. The x component is going to be the square root of 3 over 2. And then my y coordinate here is going to be 1/2. Ta-da! We filled in one of the points. That was a lot of work for one point, but we did it. Hooray us. And now we have done that work, we can actually use that knowledge later in our unit circle, and we'll talk about that in a moment. But let's go to our next point here and figure out what the coordinates are going to be for this point going out here. And again, let's turn this into a right triangle by drawing it down to our x-axis here, and realizing we need to get this side length and this one to get our x and y coordinate. And luckily we already know the hypotenuse, it is 1. And hey, we already know this angle here, it's 45 degrees, we already wrote that down. So this here is 45 degrees, we have a hypotenuse of 1. Hey, that means this is a 45 degree 90 special right triangle. And so let's look at what we remember about 90 triangles. Well, if you remember, a long time ago, a few days ago, we learned that on a 90, if one of the legs is some distance a, the other one's going to be the exact same. And the hypotenuse is a times the square root of 2. Well, we know the hypotenuse right now. That means we know this. We want it to convert to be the side length. Well, if the hypotenuse is the side length times the square root of 2, if you want to get that side length, you're going to take your hypotenuse and divide by the square root of 2. Will give you that side length. And so if I take this, do 1 divided by the square root of 2, that's going to equal this. But if you remember not too long ago, remember that if you have a radical in the denominator, you have to get it out of the denominator. So we're not going to write 1 over root 2. We're actually going to times the top and bottom by root 2 to get it out of the bottom. So that makes the square root of 2 over 2. So that's going to be this side length here, square root of 2 over 2. And since we already got that, and since it's a 90 triangle, these two legs are the same distance. And so I can come here and say this is the square root of 2 over 2. And I'm actually going to rename this guy over here y, because x and y on our coordinate axis there. And I found out that if the hypotenuse is 1, the legs are both going to be the square root of 2 over 2. So now that I know that, I can come back to my unit circle. If this is 1, then these sides here are going to both be the square root of 2 over 2. And I can fill in my coordinate here, root 2 over 2, root 2 over 2. All right, so now we've done all that work. You've actually done the hard part. So the hard part is just like figuring out what the basic ones are, because every other point on this unit circle is a mixture of these, whether they're positive, negative, or they're in a reverse order. Let me show you why that works that way. So let's go to this 60-degree angle here. And if I draw my right triangle, I'm going to get my right angle here, and this is going to be 60. And that means this guy up here is 30, because it's a 30, 60, 90 triangle. Hey, we just had that triangle over here when we were trying to get this point. Well, how is this triangle related to this one? Well, it's just a matter of reversing the coordinates. So this used to be 60, and that was 30. Now we have an angle down here that's 60, and the angle up here is going to be 30. So when you reverse those, you actually just take your coordinates and reverse them to get to your coordinates for this 60-degree angle. So I'm going to write 1/2 and square root of 3 over 2. Well, that's the first quadrant, the top right quadrant there. So if I compare that to my left side, I can actually write out another right triangle. You just connect this here, got a right angle, and there's my hypotenuse. Well, this is 60 degrees again, and that means this side over here is 1/2, and this side over here is square root of 3 over 2, and this side's 1, and that lets me know that this x change here is 1/2, and the y is 3 over 2, but since it's on the left side, this x-coordinate is going to be negative because it's to the left of our origin. So these are the coordinates for this point here, and it matches up with this angle, the 120-degree angle. And this pattern continues. Right? If you look at this right triangle here, it has a 45-degree angle here, which means, and the hypotenuse is 1, so this is root 2 over 2. This side is root 2 over 2. And so my coordinates for this point here is going to be root 2 over 2, root 2 over 2. But the x-coordinate, again, is going to be negative because it's on the left side of my origin. And so I can fill that in. So now that you've kind of seen the pattern, I want you to go through the rest of the unit circle and fill in all of the coordinates. And that'll be video 2 on getting the coordinates for unit circle.